We're going to look at trig functions in paper 2. For trigonometric graphs, this is basically going to be it, as understanding the different shapes we can have for our trig. So our trig graphs should look like this, and we're going to take a look at how each one of them affect our graphs. We need to understand things such as the amplitude, the period, which is going to be 360 divided by k, right? K is that value over there. So that one changes, and then this is only for sine and cos graph. For your 10 graph, it's going to be 180 divided by k, again, k is that one over there. And then we're going to look at different types of shifts. We have a horizontal shift, a vertical shift. We also have stretching. So let's take a look at that. Okay, let's have a look at the graphs we can have. Let's start with our normal sine graph. Yeah, this is a normal sine graph. Let's move it from radians to degrees. And we just want to see a span of, let's say, between minus 180 and 80. I would love to section 0, so you can see between minus 180 and 80, this is what it looks like. Let's actually start with between 0 and 360. Okay, so this is what our normal sine graph looks like. Then we're going to see how does the amplitude then change our graph. We're going to change that to an amplitude of 2. So as you can see, all we're doing is actually multiplying the y values of the original graph by 2. So you can see here, if we say 0 multiplied by 0, it's still going to be 0, and thus the point 0 still exists. But other points like 90 and 1 will turn into 90 and 2 because we're just multiplying the y values by 2, right? We're just multiplying the y values by 2, so they just go up by 2. We can also reflect it about the x-axis by having a negative value there. Let's remove the 2 so we can clearly see it. So what happens is you're just basically multiplying your y values by a negative 1. Again, your 0 will stay a 0 because anything multiplied by 0 is still a 0. But here where we used to have 1 and 270, we now have 270 and negative 1. Okay, so what else can we do? We can then stretch out or compact in our graph. So we can have something like 2. So remember now your period is going to change from 360 to 360 divided by 2. So you can see that the graph will repeat itself after every 280. And values such as 90 and 1 will change to give you 45 and 1. So here you're basically dividing your x values of your original graph by 2. You can also multiply them by dividing. Let's see how that division works. Okay, so here you are dividing them. Let's extend in, let's increase our period. We want to see up until 720. So you can see that the graph start repeating itself after every 720. So now your period is going to be 360 divided by a half, which will give you 720. So where you used to have 90 and 1, you will now have 180 and 1. So you are then multiplying your x values in a sense by 2. Okay, we can also move it to the left, right? So you are moving your x value to the left where you used to have a value of 90 and 1, you now have a value of 60 and 1. So you have decreased that by 30 degrees. So putting a positive will decrease it by 30 degrees, whereas putting a negative there will increase it by 30 degrees. So your original graph, which is the red graph, usually turns at 90 and 1. This one should turn at 120 and 1. We can also move the graph up and down. So you're basically just adding to the y values of your old graph. You're adding just a 1 to all the y values. You can see all the y values went up by a point of 1, and you can take it down by saying minus, and all the values will go down by a value of 1. Okay. Then what we can do again is, let's now look at how, so the sine graph and the cos graph are basically the same thing. So whatever changes you saw to that, you also see with your cos graph. So now let's do the tan graph. Okay, so this is what your tan graph looks like. Note that it has asymptotes. It will have asymptotes at 90. Let's decrease this here to, we just want to see up until 360. Or actually, let's go from 180, negative 180, all the way up to a positive 180. Okay, here is our graph, and you can see there is our asymptote, and that is one of our asymptotes there. So again, with this graph here, we can have a change in our amplitude. Let's see how that's going to affect this. Okay, so changing an amplitude, all it does is that it increases your y values by 2. So you used to have 45 and 1, should be somewhere here. This one is much harder to find because it's not an intercept or a turning point, right? 45 and 1. You will then have then 45 and 2, and get it somewhere there. So all your y values are basically multiplied by 2. Right? You can also reflect it about your x-axis. Now your graph is a reflection about the y. So there we go. Reflection about the y-axis is what I meant to say. So you can see here, all you're doing is just multiplying your y values by, did I say -1? But this is actually a reflection about the x-axis. So you just tend the graph around. My bad, yes, you've just turned the graph around. That's all you've done here. And then you can see that reflection here coming about. So this graph is reflected that way, and that graph is just reflected that way. Okay, and then we're going to move on to the next one, which is plus 30. Okay, so plus 30, you're moving it, and you'll clearly see that, oh, this one is going through the asymptote of the red graph, right? It's going through the asymptote because your asymptotes are also going to be moved. So for a second, let's close down these asymptotes, right? So we're used to having them at 90, but we're now saying we're moving it to the left by 30. That means your asymptotes will also move to the left by 30. And now you're going to have, let's say, let's actually do it here so you can see it. You're going to have a plus, a minus. So in terms of number, it will say minus, not a plus. And then here we will have also a minus 30 on this side. Let's switch them on, and you will see they will fit nicely to our new graph because we've moved everything to the left by 30 degrees. Even our asymptote now is at 60 instead of 1 minus 120 instead of being at 90, and the side it will be at 60 instead of 90. All right, and then the graph has moved to the side by 45 degrees. So here we used to have 45 degrees, so let's just close these and let's look at our line where we used to have 45 and 1. We should have 15 and 1. So let's look for it. There we go. You can see that 15 and 1 where we used to have 45. Again, we can move it to the right. Okay, so this side, we just want to see the asymptotes. Okay, so let's close these and open these too, so we can see that the asymptotes fit in perfectly. They are now at 120 on this side and a negative 60 on that line over there. And again, where we used to have 45 and 1, we would then have now 75 and 1. So we can look for it there. There. We now have 75 and 1, so we've shifted it to the right by 30 degrees. And then we can move the graph up and down. So let's go back to our original. Okay, so this is our original. Let's put in our x there, and then we can move the graph up. So all of our y values will increase by up. So where you got 45 and 1, you will now have 45 and 4. Okay. So you're moving all the values up by 1, and you can also move the values by 3, and you can move the values down like that. So all the values go down by a point of -1, and that's just you having to understand that. Now, with this trig ratio or trig functions, they will also ask you the same things that they will ask you in any functions, right? So questions you should expect on this is your x-intercepts, this is where now your y is equals to 0. You will have your y-intercept. This is now where your x is equals to 0. They will also ask you things like, maybe they gave you two graphs, one on top of the other. They can ask you for which x value is your g of x greater than your f of x, right? For which value is your f of x multiplied by your g of x less than 0. So here they want to know when you multiply them together, when you multiply your y values, when do you get a negative, right? They can ask you when your x multiplies your g of x again, when do you get positive values, meaning both of them need to be positive for you to get positive values. So you need to be able to look at your graph and those. You can look at example of these questions with regards to the exams on past things that we have done.